Let me tell you a couple of words, of course, about the presentation and what we're going to be doing, and what is in general the schedule for today. So we've got this presentation that lasts 45 minutes. It means that it's pretty intense, and it means that we're going to be doing lots of demos, and we're going to be driving lots of conclusions, and that is pretty much the background. As you can see, I'm Paula Januszkiewicz, and what I'm doing for a living, it's a couple of things. Cybersecurity for the past 16 years, so that's quite a lot. I'm the CEO of the company Secure. This is the company that celebrated 13th anniversary, let me think, 8 days ago, something like that. So this is the one that I have established. At the very beginning, I was the only one. Right now, there's almost 50 people on board. So that's quite funny because nobody in IT teaches you really how to have this business role. And my job has been always cybersecurity, and I kept it this way. So other guys are doing all the sales part. I do what I like to do, and that's cybersecurity. My job has been always pretty much the same. Yes, so not only pen testing, but also incident response and also forensics. And these three things, they connect very well together if we know the background of the various operating systems. Not only Windows, that I'm going to be rather focusing on, but also Linux, that I work with every day within my cybersecurity activities. And long story short, I'm also the Microsoft Regional Director. That is quite a funny role for someone who is not working for Microsoft. So not working for Microsoft, not being a director. So what is this, yeah? And that is actually quite an honorable role given by Microsoft to someone who is converting, as they say, technology into something innovative. Okay, I'll take that, why not? And that is pretty much the background. Now, my background from the speaking perspective is pretty straightforward. As long as, of course, there is someone to listen on cybersecurity, then it's great. I had a chance to deliver as well keynote at the RSA in San Francisco. That's like the biggest security conference. I still don't know why someone wanted to listen, but apparently cybersecurity is becoming a very popular subject, so that is something that it's important to talk about. Also, of course, participating at various Black Hats from like, I think 2016 or something like that, maybe, yeah, something around that. But who would count that? Cybersecurity changes every day, every year, and there's always a need to adjust. That's why, for example, especially from the 2 days perspective, we're going to be focusing on the 10 skills, the 10 different ways to make hackers excited. And this is the background that I would love to start with. So within our team, and just to give you also a little bit of a background, we deal with various situations. And for sure, I must say, before we start, one little story, that we've never seen so many situations, so many projects like during the pandemics that are reflecting the hack at the customer side, maybe the ransomware or something like that, and then eventually they call us, we have to come over, and then the whole party begins with like who's going to pay the ransom, on who's going to recover the data, and so on. So the reason why I'm saying that hackers are like water is because like literally every week, or even like a couple of times per week, we've got a call for incident response. Not that this is our main job. Yeah, our main job was supposed to be penetration testing, but apparently our customers or future customers, they're like, we've got a problem, we've got a hack, or we've got something going on, please help. And when we take every project into one bucket and we summarize it, what was happening during the pandemic, we learn that these points of entries that hackers choose are pretty straightforward, pretty simple. Yeah, for example, using the known examples that you guys are familiar with, we had a case with the Colonial Pipeline. Do you know what was the point of entry for these guys? Simple password. So imagine that there is a big pipe going through the United States from east to west, and it's like a serious stuff. And then hackers manage to get access just because there is a simple password. So a similar story was actually for SolarWinds, right? For Orion Software, where there was actually a simple password as well that was used by one of the, as they said, interns. Whatever, whatever there is someone to blame, I don't know, that's just my ironic opinion out there. But long story short, these kind of points of entries are simple, and that's my point. Also, the same story happened for Irish healthcare, where people were asked to pay $20 million for hackers encrypting patients' data, and they were literally stopping the vaccinations, testing for COVID and all that stuff. So it was actually affecting human lives. And hackers said, nothing personal, we're just businessmen. If you pay, you're gonna get your data back. I mean, it's simple, right? So eventually they had to negotiate with the hospital that they're gonna pay less money. And this is what I would like to start with, that during the pandemic, we actually had a very interesting project that we participated in. And when all of the countries were in lockdown and you were not allowed to travel, also same story with you guys, because I actually work with a couple of people from the Netherlands too, in a team for one of our customers on a global level, where this was a series of factories, and we had to all travel on site on various government passes. So no quarantine, nothing. So you could still travel. It was just quite a lot of paperwork. And we got to the customer side because all of their stuff that they had, including the VMware drives and all this stuff, it was simply encrypted. How hackers managed to get in? Through a vendor. So I think this is actually pretty nasty, because you've got an IT company that supports you and you kind of trust them, but they do have privileged access. So thanks to this privileged access, they actually managed to get access to the customer's network. They encrypt everything that moves pretty much. They spend there a little bit of time. They figure out what is important, what is juicy, and they hit this. Now, funny part about that was that when they encrypted the data, of course, they made a call like, hey, if you want decryption, you have to pay. There was a negotiation company hired for that because they wanted quite a lot of money. We managed to negotiate down to €500,000. So that's quite a lot too, right? And the best part of that, and that's literally my favorite part, is that they got the decryptor that wasn't working. So quite a nice shopping, yeah? You pay for something $500,000, then you get nothing. But eventually, what we did, we decompiled the decryptor, and we learned a couple of things. So it took us a couple of days though, but we learned a couple of things, that hackers nowadays, they take super simple path that is very cheap in some sense. So they are not very well prepared for the encryption and so on, but they do anything they can to make your life miserable at the lowest possible cost, meaning what they did, they have encrypted only the first 8 megabytes of every single file. The middle of the data was clear text. So if you got like a 1 terabyte database, it's not too bad. Maybe you are able to recover from that level. And then the key was at the end of the file. So we started to figure out, knowing the algorithms, also the ways how they were used and everything. And then eventually we managed to decrypt their data fully, but we did it manually because that decryptor was just messed up. So it was the software that wasn't tested, wasn't working, and so on. So quite a painful situation, because that really stopped their operations. And the problem was that this was a series of factories in the whole world that were affecting the economy of one of the countries. So eventually that was quite a serious story that shows that good backup strategy, it's everything, and they did not really have a backup. And they were managing the database where they introduced the paperwork since like 1965. So they were relying on the data and then no backup. Something is wrong there, yeah? So eventually, this is what we've been dealing with. Now, what kind of conclusion we come up with is that there are a couple of things that whenever we work with various situations, and whenever we analyze what happened at the customer side after the attack and so on, we're learning that these points of entry are very, very straightforward, very simple. And this is what I would love to show you, that sometimes small fixes can help us to get rid of that kind of situation, or in general avoid the situation, and make simply hackers to pick someone else. So the first part, and this is our top 10 ways to make hackers excited, it's related with the misconfiguring the firewall. Now that sounds very simple, but let me tell you what I mean by that. First of all, whenever we are thinking about a firewall, well, of course, whether it's enable, disable, and so on, this is a subject of like 90s, yeah? But what I mean by misconfigured firewall, it's that we are allowing stuff that we don't know to communicate out from the computer. So for example, I do have some, let's say, macro that I'm firing up as a part of the attack. So there's a phishing email, there is a macro, there is a child process opening, there's a PowerShell underneath connecting out. And the question would be why that PowerShell even connects out. So why do we allow processes that we don't know to communicate out? And one of our customers during the pandemic implemented a very cool approach. They were a little bit on budget. And they wanted to increase network security for them. So what they did, they have configured firewall in a way that it was disabling all the outgoing traffic. So literally the Windows firewall to disable all the outgoing traffic. And they were only allowing certain processes to communicate out. So you can implement things like AppLocker and so on. So Sami, I'm sure, was also talking about that. But if you do allow PowerShell eventually, so there's like PowerShell that can run on all of the levels. So the point is basically to also block it from the network perspective. And why is like that? Because again, experience shows that quite often within the attack, the macro PowerShell underneath or C script underneath and so on, or in general the command prompt underneath, are the ones that are used to fetch the encryption keys from the internet, and then you're encrypting your data. And that will never happen if that communication wasn't simply done. So with this kind of a free, simple move, we are able to assure that this is just not happening. What I would love to show you, it's a demonstration that we've got in here with the hacker listening on the port. So this is basically what we've been explaining. On the right side, you can see that there is actually an Outlook with the macro that someone's gonna open. Yeah? So this is a simple situation where here we're gonna just do open. We're gonna see, of course, that there is a macro underneath. As we can see, okay, whatever settings. Then there's this document created in the earlier version of Microsoft Office Excel, which is obviously not true. We are enabling the content, clicking somewhere inside, and then we've got a reverse shell opening. So that's classic thing. That reverse shell is actually underneath, done in a very interesting way, because if you go to the Visual Basic, here you are able to see that we are actually having one big button over there, and then we are downloading the text file, which with certutil, we are decoding from the text file to an executable. Certutil we are able to use for download, but we are also able to use for the conversion. And then we are firing up the ref_kali.exe, which is actually a reverse shell. Now over there, you can see that we've got whoami/all, and then the next part is related with the fact that we are here, Paula. Yeah, so here we go. And then the next part is going to be to actually use the vulnerability that's going to be within Windows. Now, we're going to be talking about many situations here. Let's just push it a little bit farther, because here we could be regular user. Yeah. So here, what we're going to do, we're going to get the script over there, and that's the privilege escalation script with the PowerShell. So here we go. And then we've got this. So this is the ESC escalation PS1 that we are able to execute. And then the next part, within the PowerShell, we can, of course, within the reverse shell also run it, yeah? So we're gonna set up the execution policy to bypass, and we're gonna specify, of course, the scope. And then the next part is gonna be to execute that script to leverage that particular vulnerability in Windows. Now, the thing is that over here, we are able to see that we've got a possibility to hijack a DLL. Now, what does it mean? It means that you are able to drop a DLL into the folder. So this is more like searching for misconfiguration to the folder that is actually loading things at the startup. So in this case, it's going to be Python, unfortunately, because for me, Python environment starts pretty much immediately. So the next part, it's going to be to set that up. And in this case, we've got also the reverse DLL that we're going to get. And that reverse DLL is actually something that we're going to drop into Python, and we're going to name it or override it within the DLL that is originally loaded. Yeah? So we can imagine that if there is something running at startup, it's going to be immediately loaded after the reboot. So now, simply, we've got a new DLL that was actually loaded over there at the startup. And then the only thing we will need to do on the client side is just to shut down the client, and then we're going to see whether we are able to actually get the connection. So here we do the netcut, and we're listening for the incoming connection. And in here, the next part is related with the connection using the reverse shell that we got over there. So vulnerability really is misconfiguration, and it's a matter of possibility to overwrite into the folder where we've got these DLLs. And as you see, we've got over here that possibility to actually do the who am I and we are anti-authority system. Why? Because Python at that level managed to actually load as a service with the local system privileges. So this is a very simple thing, right? But on the other hand, what I wanted to show you is that we could stay over there a user. And within this session, also within the closing keynote that I've got, I would love to show you a couple of other interesting perspectives that when you are just a user, question of the universe is how far can you go? And quite often you can go far, unfortunately. Even though we got like super nice security mechanisms out there implemented, we are still able to escalate a little bit further using curb roasting attack, using SMB relay attack. So being a user, it's not that bad. Here we played a little bit farther. So we can see over here the next part, which is related with the overly simple passwords and MFA, multi-factor authentication misconception. We all say that, hey, use MFA because hackers do password spray. Colonial Pipeline that we mentioned, SolarWinds that we mentioned, these are all password-related attacks. Yeah, things like password one and so on was their use within the attacks. It's mind-blowing. So we could be like, yep, answer to that, it's MFA. Yes, but you wouldn't be here, I wouldn't be here if everything would be okay with MFA. Problem with the MFA is that it's good when you only strip it within one context. But when you combine it within the further attacks, MFA, it's great, don't get me wrong, I will always say that, but it's not protecting us fully if we use it within a multiple contexts. And let me show you what we mean by this. Within the attack, I'm gonna use something that's called Evil Jinx. Evil Jinx is actually a software that you are able to use to simulate various attacks on identities. To be fair, it's a great software, even to play around like by yourself. So we also use Evil Jinx, for example, to deliver the identity attacks to the companies. Yeah. So here we go. What I would love to show you, it's the use case of Evil Jinx, where we're going to be playing with simply the attack on the multi-factor authentication. So Evil Jinx goes first. Second part here, we're going to use the Laris get URL, so to generate URL for Teams. So this is actually login teams microsoftonline.com.co. Since when we've got .co? We don't. .co is actually a domain that we bought. And crazy that it was available, right? But anyway, we bought a certificate. So it's all trusted. Nobody said anything. So here we go. Certificate, all good. Yeah, unfortunately. But anyway, it's a great domain for the pen testing. So we're going to log in with the Abby at Secure Ninja. So user does this, let's say. So we send it to the user and so on. And then approve sign-in request. This is a classic multi-factor authentication, and user will approve it within the Microsoft Authenticator app, and then stay sign in. Yes, okay, fine. So here, what we managed to capture, here we are, by the way, redirected to the regular Teams, but what we managed to capture, it's a password and a username, and the best one is that all authorization tokens intercepted, which means that we managed to capture the authentication token to Teams. Now, if we do logons, here you are able to see that that's the cookie that we're going to be using for the authentication. So why don't we just use it? So what we're going to do, we're going to open a website right now with the portaloffice.com to bypass multi-factor authentication. So here we can specify, of course, the username and so on, but who would care? We have everything in the authorization token, yeah? So we're going to take that. Here we go. And then the next part is related with submitting that cookie into the session. So we can do that by the add-on, and then simply let's clear what we got over here, and we're going to add new cookie over there to provide us authentication to the portaloffice.com, and then approve, and then refresh. As you can see, we are logging on as that particular user without the need of multi-factor authentication, and that's the guy that we were touching base on. So again, just to put it in a context, yes, I really love these kind of situations because it's like similar to one more technology that I will allow myself to compare with. You guys know the credentials guard, yeah? So this is basically something that protects identity in Windows. And Microsoft talks about it, and I'm not against it, don't get me wrong, it's awesome, but it's just like one drop in a sea. So credential guard allows us to protect ELSAs, but what about impersonation privilege? We are also able to take over all of the identities just like that, even though credential guard is there. So why don't we talk about the fuller picture that we got within the operating system? Same story here. Yeah, so it's like multi-factor authentication is great, yay, but if we do put it in the certain context, it's not that great anymore. So basically, what we should combine it with, if it's about security, it's the anti-spam, anti-phishing filter that works well, that will filter out things like microsoftonline.com.co and so on. Yeah, so this is the story. By the way, we bought this domain like 2 years ago. Still works. It's not blacklisted. I don't know how that happens, but here we go. Okay, so we've got this one. Now, another part that is related with various attacks, it's the case of a no network segmentation. Now, this is also one of the things that makes hackers' life more excited, because imagine, hacker manages to get access through phishing. Phishing executes as a regular user. Let's be fair over there, not an admin or anything like this. And then we are connected using VPN to the organization. What do we see over there? Yeah, so we've got a case of a shadow IT. We've got a case of things that are misconfigured over there, vulnerable over there, and so on. So question is, what kind of, eventually, segmentation or any kind of like a stoppage that we got that will prevent users to even see these resources? User needs to only be redirected to the resources that they need, and that's it. You know, again, beauty of pandemic showed us one situation that when all of the organizations, they had to switch to the remote work, everybody started to use VPN massively. It's like everybody was in travel. It's the same situation, right? So the problem was that when you've got like a couple of traveling users, then the risk is small. But when all of your employees are traveling, then the risk is much, much bigger, because then question is, as we mentioned before, what do they see? Did we test that access? Did we test the VPN access? And in vast majority of organizations, answer will be no. So what the hacker can do, and that's the exciting part, hacker can pivot through the workstation. So workstation of the user is working like a proxy. So hacker won't directly connect to the network because he or she will be discovered, but it will actually set up a route on the client in order to jump further through the client computer. So who is really communicating with all the servers? It's a workstation of your user. Yeah, so that's doing the bad stuff. Let me show you this. So as I mentioned, lots of demos. So eventually, we've got over here user Mike. And this is basically, Mike is actually our team member from Secure. And over here, we've got two machines. So we've got a Windows 10 and we've got a Kali Linux. So within the Windows 10, we've got a situation that we would like to, this is the user's desktop, connect to the internal resources. So we're gonna do ping srv01 raccoons.pl. And we're gonna do the same story on the server level. Yeah, so we're gonna browse it by the browser. We've got a srv01 raccoons, and then it doesn't work. Why not? Because we are not obviously connected using the VPN. So this is quite a simple scenario. So in this particular story, what we're gonna do, we're gonna connect to the VPN. And as you can guess, we would be able actually to access the internal resources. Yes, so let's confirm on that one to be on the safe side, ping srv01 raccoons.pl, and at the same time, we're gonna refresh this page. Page is working. You can see that we've got a JBoss application server over there. So this is all nice. And then of course, we're gonna be here having that ping, so echo reply visible within our console. So kind of clear situation. Now, the problem is that if this workstation would be somewhat vulnerable, or user's gonna become a target for phishing. So this is what we've been already discussing. Yeah? So user, for example, clicks on a link, opens the attachment, whatever. Here, we're gonna be acting as a hacker. And as you can see, we've got a network that is unreachable, not yet at least. We're gonna do the port scanning because sometimes ICMP is blocked and then still doesn't work. Okay, so we are planning the attack on a user. And we send user phishing email or anything like this. And then eventually here, you can see that we are as well from the outside of the network. So it's 192.168 and so on. And when the user clicks on the link, we're gonna connect to the user's desktop and then take over the communication. And this is what I would love to show you. So the next stage over there, it's going to be go to the Metasploit. And this is probably the simplest possible use of Metasploit. So we've got a set lhost, set lport, set payload Windows x64, and so on. So we are here configuring the simplest possible handler/listener for the incoming connections. So if the user, for example, clicks somewhere within the phishing email, we got this. Yeah, so this is easy. Okay, so we're going to be playing with this one right now. So we've got a listener that is set up. It's not running though yet, so we're going to run that. And we're going to do exploit -j -z in order, of course, to start that particular listener. And right now, phishing happens. Yeah, so I'm saying it, just imagine that because we already did that. User clicks on the link, for example, and then we've got over there session 1 opened. So we are right now sitting on the user's desktop. So that's actually pretty cool. And we can either see over here that we've got a communications, we've got an IP address from the same subnet as the user. So that's technically still not inside of the organization, right? So in organization is going to be a different set of IP addresses, but this is basically 192.168.201 and so on. So our goal is going to be to actually add root to that user's workstation in order to do something that we call VPN pivoting. So here, sessions, and we are here interacting, so -i1 with the user's session. So here we go. Now we can get into shell. We can see that we are particular user, so we can do the who am I just to verify. We are that user that was sitting there before. Host name, that's clear, user's desktop. And then the best ipconfig to verify one thing, that not only we are within the same subnet, but also we've got a VPN connection. So that's this 10.10.10.151. So it's good. And we are like, it must be the company. It must be the remote work case. So why don't we just add root to this connection in order to do the proxy through the user workstation to get the company's resources? So let's see what we can do. So the next part, it's going to be the PowerShell. Let's just do it. And we're going to play a little bit with the data protection API over there, because we can, for example, execute the OVPN script. It's a publicly known script to get the passwords that user has stored for the VPN. But if we leverage these passwords, we're going to be discovered. So it's better to stay on the user's computer. So we will not be really sitting there. The only thing we're going to do is to configure the proxy settings in order to go through this user computer. So that will be the best part. So let's exit the consoles. Over there, exit. And then over there, we're going to specify the connection. So we're going to be here using the proxy, so the SOX4A, in order to configure that one. So if we move everything to the background, we can get into the next part, which is, of course, interaction with the session 1. Yeah, so just a reminder that that's this session that we have all the time ongoing. Yeah, so if we're gonna use auxiliary and then server SOX4A, so here we go, we will be able to actually set up the proxy. So show options over here, show us that we've got a SRV port 1080. That is actually the port that we're going to be using for proxy. And then the next part is to do the root add, and then basically we're going to specify the subnet that we got. So that's the 10.10.10.0 to 255.255.255.0, and then we're going to assign it on the session 1. So the session ID is the one that we are using it for. Yeah, so that's why we've got this 1 at the end. So this is where it comes from. So it's actually super easy attack. Super easy, a lot of explanation, of course, but it's a quite a straightforward situation. And then we're done completely. Now we can do run, and then we've got our proxy running. We are proxifying through the user workstation right now. So we can verify whether we've got access to the network. So we can do nmap like this, and this won't work. But if we go through proxy by setting up a proxy chains within Linux, then let's use this proxy chains. Here you're going to see that we indeed is going to have the full connection to the inside of the infrastructure of that company through the user's computer. So as you can see, we've got a communication, for example, on our port 8080 that we were running the the server. So this is the server that we had no access to in GUI, but right now we're going to have access to if we're going to run, for example, the proxy chains through the Firefox. Yeah, so we're going to have proxy chains and then Firefox, lovely. And then the next part is to hit, of course, our server that was SRv01, but indeed IP address was 10.10.10.20 and port 8080. So this is the situation where we are able to push the traffic to the user workstation, but just being a regular user. That's the thing. So beautiful part about that is that network segmentation is something that would stop us. And because we quite often in the companies don't have it, hackers have access to lots of resources, at least from the visibility perspective. We don't, maybe they're all secure, yeah, but we are able to see them, and that's already bad enough because we are able to play with the network, to shuffle the traffic, maybe to do a little bit of a spoofing. Then it's the next stage for the attack, and this is something that brings us another problem. That's why the next problem that comes to the field, so we are moving every step deeper, it's a lack of SMB signing, and that is actually one of my favorite attacks, to be fair. Because SMB signing is something that is not a default setting. So we use SMB, we just connect to the network, but there is no signing implemented. Quite often it comes from the fact that it might be a matter of compatibility, but on the other hand, we may want to exclude some solutions from SMB signing in order to be able to communicate safely in between the, for example, Windows machines or various network appliances and so on. It's all possible. So SMB signing, it's a big deal. And what I would love to show you, it's a simple demonstration where within the SMB not signed, we will be able to perform various attacks. So here we go. How that will work. First of all, within the virtual machine, I've got two consoles here running. One is like Python SMB relay X, so we are using the in-packet master script for the attack, and we're going to be attacking the 10.10.10.250 host. So that's the one in the top, with the CQ shell 104A, and that's the reverse shell that we are able to use over here. So just to enlarge Python SMB relay X -H on the host CQ shell and so on. Now on the other side, we've got over here the, again, Metasploit. So we're going to use a similar listener as we previously used, but for a different purpose. So we're going to use the use exploit multi-handler, and then it's going to be set payload. It's going to be Windows, Meterpreter, and then it's going to be reverse _ TCP, enter. And then one more thing, set lhost 10.10.10.99, because this is our IP address. Now, next part we're gonna do is maybe for safety show options. We don't have to, but here we go. We're gonna be listening on a port 444, and we are just waiting for the connection. So exploit, enter. Now, what's gonna happen is that this one in the back is responsible for listening for one thing, which is SMB, obviously, because it's a clear text, but second, it's NTLM version 2 authentication. This is not a very nice question to ask, and please don't answer, but just think about it. How many companies you know that actually get rid of the NTLM version 2 authentication? Because I know amongst like hundreds, just 2. And they were not doing it perfectly. Yeah, so NTLM version 2 is bad. When do we use it? We use it when we do / IP address or / short name. That's it. Yeah, so of course answer would be, why don't we just implement fully qualified domain names that we do it? Or maybe we could only enforce Kerberos on that kind of names, or we just cut off NTLM version 2. Sincerely, for all of these things, you have to do a little bit of analysis, which is definitely the path to take, just saying. But unfortunately, this is the attack that when I do my pen tests, I always start with this, because it always works. It's actually quite boring, to be sincere. Like when I even talk about it, I'm a little bit bored, sincerely, because it's like your everyday task, yeah? So this way. So let me show you one thing. What I'm gonna do on my side is I'm gonna basically trigger / access. So I'm just gonna query the IP address using // So that's it. So not a big deal. I've got that machines somewhere out there. So I'm gonna get into this one. Okie doke, I got it. And then I'm doing it right now. And on this side over there, you can see that there is session opened. I'm gonna do PS to list processes. I'm already in, by the way. So SVC host running as system 664 process ID, migrate 664. Sorry for running so fast, but I have only 15 seconds to respond to this query. And worked great. Migration completed successfully. Migration, this is such a nice word for injection. Yeah, that's like what they do. So if you do shell, then who am I? We are a system. Is there any vulnerability? No. It's just a communication in between the protocol for authentication, SMB not being signed, and correlation with lack of whitelisting. Because if there was whitelisting implemented, then this piece of code here won't run. So that's one thing. Second, SMB, if it was signed, then lots of security comes to place. And also anti-LAN version 2, which is the hardest to kick out. If it was not there, then this problem would not even happen. So one of these things would help. Yeah, but quite often we see that that's unfortunately not helping. Okay, so could that be something that makes hackers' life excited? Yes, absolutely. So summarizing, allowing unusual code execution is actually one of the two solutions over there. Because if we would not allow executables that we don't know, if we would control how PowerShell is used, how various DLLs are communicating, VBS and all that stuff, then we would be able to nicely prevent these kind of attacks. Therefore, it takes us to the next one, which is no whitelisting on board, makes hackers excited because we are able to execute what we want. Yeah, and of course, antivirus nowadays, if it's not intelligent, if it's not based on machine learning, if it's not correlating the events, you can trash it because for lots of situations, you are able to bypass antivirus while, for example, executing malware directly from the memory. And happy, of course, to pass more information about that. It's not really a session about that, but we actually have a custom executable changer, let's call it this way, that makes an executable that is recognized by antivirus. You drop it through our engine, and then it produces you a new executable. We use a custom reflection technique. You drop it to VirusTotal, it's all green. And this is how it's going to execute directly from the memory where it's going to compile or decompile. Yeah. So eventually, we've got that kind of situation. Okay, now, one of my favorite parts, to be sincere, I don't know how about you, but I really like to play with old stuff because it's easy, you don't have to struggle, you can crush it, and it's most cases it's going to crush successfully, so it's pretty cool. What we are talking about here? SQL Server. And I'm pretty sure that for all of the companies that you know, SQL Server, it's there. And what I would say, it's going to be quite challenging, so forgive me this, but that challenging thing is that I've never seen an organization truly, for my whole life, never seen, where there was actually all of the SQL servers, all of the SQL servers configured securely. There's always something that is configured insecurely. And the question is, what do we mean by insecure? First major mistake is related with something that we call TDS. TDS stands for the tabular data stream. This is the communication protocol in between SQL Server and the app. Whatever app you use, you could use the SQL Studio, Management Studio on the other side, it doesn't matter, that communication runs in a clear text. So imagine, because I'm kind of coming from the old times, however that sounds, where SQL Server was implemented by admins, not the SQL Server security specialists, you know what I mean? Like you just take the SQL Server installation, then you're like, blip, 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 and then you got a database, yeah? So of course we could set up like accounts because we want to be like more secure and we don't want to run it as local system. We are not allowing XPCMD shell, blah, blah, blah. So yeah, that thing's clear. But what is forgotten, it's the network communication. That TDS, tabular data stream, it's a clear text. So if you are within the same subnet, if you do sniffing, you are able to see that communication and you are able to change these queries on the fly. Like this is, to be sincere, this is also one of my favorite parts to do within the network, because like where everybody secures the platform, network is very poor. So, demo is coming. What we got, in here, it's a situation that we've got a database. So this is the SQL Server database where we've got just a query, select customer ID, company name, contact name, address, blah, 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 from customers. Okay, so we're going to query that. And as you can see, where we're going to execute this particular query, this is something that's going to actually give us the output from the database. So nothing bad over there yet. So next part is that we're going to refresh the logins. And the reason why we're going to do it, because I would like to show you how to create a user in SQL Server by just being in the same subnet, okay? So again, nothing misconfigured here besides big issue, which is encryption of the network. Of the connection in between SQL and app. Yeah, so this is the setup. Okay, so this is all clear, and our job right now is going to be to go to the machine where we're going to be performing the sniffing. So in here, we're going to run the Wireshark just in order to see that these queries are actually running within a clear text. So that's going to be the setup. And that particular clear text queries can be also changed. So within the Wireshark network analyzer, let's run it. Here we've got already the filter TDS set up, so it's all good. So we can do right now the capture, start, and we are right now capturing, of course, all the TDS traffic. When we're gonna do this query, so this is the best part, execute, then here you're getting the response, and one of the things that you're able to see is that we've got a select here, and then this is clear text, so we can go into more details of these queries. So let's find the query really, and this is the one. Select customer ID, company name, and so on, so it's all clear text. So we are able to change it on the fly, and the best part is that we are able to replace it. And that is exactly what we're gonna do. So not only you are able to affect what's gonna be in a database, but you are able to completely change this query in order to be executed on the database. So good thing to see. Now, the next part, it's gonna be related with the Linux, where we're gonna set up of course, the query replacer. So that's the SQL inject. What SQL inject does all together with the ettercap, it sniffs the network and it allows you to capture the patterns, and it allows you to also change them on the fly. So this is the power of SQL inject all together with the ettercap. So here we are actually specifying select customer ID, company name, and so on. And then we are replacing it with the create login hacker with password 1. And this communication is going to happen in between these two hosts, leveraging ettercap. So long story short, what we're going to do now is that we're going to still execute that query. This time, commands completed successfully. So it's a different answer than what we had before. And here, within the Linux, we are able to see that found our string and replaced it. Here we go. And that also gives us a possibility to go back to the SQL Server, refresh the logins, let's do it. And then, of course, as you are expecting, we're going to be able to see over here the hacker identity established in the SQL Server. Again, happening in vast majority of infrastructures of this world. Again, however challenging that sounds, but sorry to say that, that's basically what we are seeing. Yeah. How can we fix this? Apply the certificates on both sides. Build a tunnel, whatever that would be. Yeah, so that's it. So tabular data stream security. Beautiful thing to fix, actually. Trusting solutions without knowing how to break them. And that will be the song to sing on my final keynote again, because we sometimes decide to use solutions that sometimes we believe they're going to serve for security, but eventually they will not. Question will be, can we stop our antivirus? Actually, 40% of antivirus solutions on the market right now can be easily stopped by playing with the SDDL of the service. SDDL, it's the security descriptor definition language. So you're able to change the permissions for the service, and then you just stop it. And should I use some names? Yeah, why not? McAfee can be stopped like that, for example. Here we go, yeah? Defender not. And I'm not saying that Defender is better. It's just that it cannot be stopped this way. It can be stopped in a different way. So it's a different thing. Yeah, but here we go. These are the things that we are leveraging. Misusing service accounts and privilege accounts. Again, I believe Sami was also, and this is also the Sami subject was referring to this one. We're going to be talking more about that within our closing keynote, but service accounts in general are the ones that are relying in the background for vast majority of the attacks. This is an identity that's not managed. Why? Service account, when you got a regular service and it runs on the account, that account, it's not secured. So you could use the regular, let's say, SQL SVC account. Now, question is, can this account log into the other servers? Yes, no. Can this account log in interactively? Yes, no. In vast majority, yes. But it should not be. It should be denied logon. It's beautifully called locally. Of course, it's a bad verbiage in Windows. We don't have such a thing like a local logon. We don't have such a thing. We just have a logon. And it could be interactive. It could be as a service. But where we log in is a different story. We can log on against the SAM database, against the domain, and so on. While service accounts should not be allowed to log on locally / interactively. Yeah, so we can fix it within the user rights assignments in Windows. Also, classic thing of an identity misuse, and also the privilege access within the organizations. And summarizing, we've got filing for hipster tools, which means that we are allowing users to use things that are digitally signed, like things like portable apps. Things like, I really hate to give this example, but 7-zip is one of those. Yeah, so 7-zip is not digitally signed, but we all use it. You know someone who is not using 7-zip? Of course, besides grandparents and these like, okay. But anybody around, I believe, who might be, yeah? Or for sure, you know someone who uses it. So 7-zip is also a pretty good example here. How do we assure within the organization the quality of software that we use? It's hard. That's why, the reason why I'm saying it's hard, because someone signs it, and what can you do? You just buy it, and you just use it, yes? So you trust it, which is a very inconvenient thing to do in cybersecurity, but we have to do it. Therefore, what we always have to think about is how do we surround this app in order to manage what it does, what kind of privileges it uses, how it behaves, and so on. So that's why privilege access management has been more important than ever. So summarizing, intensive, right? But I don't know how this 48-minute runs, so let's summarize it. We talked about misconfiguring firewall. We talked about the MFA, multi-factor authentication. We talked about network segmentation and VPN pivoting. We talked about SMB signing and how can we leverage it within the NTLM version 2. We talked about the old protocols like TDS, tabular data stream, and so on that have no security. We mentioned the service accounts and discussed the need of a privileged access. So all these things are actually taking us to one big summary. And these are the top 10 ways that are making the hacker's life excited. What we have to do eventually is a couple of things. Take into consideration the current attacks and situations. First of all, have a really good anti-spam, anti-phishing filter that goes with a second level of whitelisting. So things like attack surface reduction rules, whitelisting itself, configuration of the firewall, so who can communicate over the network. This is the major point of entry for hackers, major. Plus, within multiple reports, phishing is actually a #1 mean of transportation for malware. So this is the first line of defense, and it has to be great. Also, misconfigurations, because if the hackers / users connect to our inside of the network, then they find shadow IT concepts. So anything that they are able to find out, they will exploit. Plus, they will also exploit the network security. And this is what I wanted to show you. Not only we've got things that might be misconfigured, but also might have things that are communicating, for example, in a clear text without us really knowing that. And of course, any tracking, so correlation of activities, usage of identity, and so on, has never been more important like today. So if you got some possibility to track every identity and how it works, where it logs in, and so on in your network, that is something that we notice that it's a really good thing to execute within the network. If you would like to download the tools that I use within the demonstration, please use the resources, secureacademy.com/tools. A username, student, password, as you can see, super secret logon data. This is just to avoid, the antivirus and all these strange things that care about the reputation. And another part is our blog. If you would like to read more hacker stories, please go ahead and check. This is where we share different things, how cybersecurity currently looks like. And if you would like to drop me an email or so, paula@secure.us is the one. Thank you so much for listening and enjoy the rest of your day.